You've reached this specific spot in the course. Now, one of the topics that comes up for discussion quite a bit is the p-value. And more specifically, how do values influence the p-value, and how does the setting of an hypothesis influence the p-value? So I've decided to make this extra video lecture just to give you a better intuitive feel of what happens to a p-value when you start playing with actual data point values, and what happens to p-value when you actually set the hypothesis. So I'm going to show you two groups of individuals with a certain variable and some numerical values for them, and we're going to change them up a bit and you'll see the difference in the p-value. I'm going to use some spreadsheet software. It's called Libre Office. Show it to you. You can download it for free. Now you can use Microsoft Excel, you can use Numbers on Mac OS, any kind of spreadsheet software, but I choose Libre Office because it's free of charge. And you can download it for Mac OS, for Windows, for Linux, doesn't matter, everyone can install it. And it has a beautiful spreadsheet software. So that's what I'm going to use. I'm going to show you these two columns and we're going to play around with the numbers a bit and get a p-value from those values. Let's have a look. As mentioned, I'm going to use the spreadsheet software that is part of the Libre Office suite of Office programs. You can find it at libreoffice.org. It's a free download, and you can choose whether it is for Mac OS, for Windows or Linux. You can install it on any system. It's absolutely free of charge, and the spreadsheet software that comes with it is quite powerful and actually can do quite a bit of statistical analysis. I've opened up LibreOffice here, and it is a normal spreadsheet program. Some of you might be familiar with it. If not, don't worry, this is not a lecture on how to use LibreOffice. I want to show you two groups of patients or individuals that form part of a research study. We see them here in Group A and Group B. Now imagine we have some variable that contains continuous numerical values, a ratio type continuous numerical variable, and you see 30 individuals here for the first group and 30 individuals in the second group, and we've recorded these values. Now the beauty about the way that I've constructed these values is every time I press, this is on a Mac, so I'm pressing Command U, these values change. They randomly change. So I've set them up to change randomly. The way that I've set them up, though, is that they do come from an underlying population in which the parameter is normally distributed. These values actually come from a normal distribution. So even though they change at random here, every time I hold down the Command key and press U at the moment, we get a new set of 60 new values. That's not the point though. What I want to show you is us doing a student's t-test. So it's a parametric test. We're under the assumption that these values are from a population in which this variable has a normal distribution. We're assuming equal variances, so we're going to do student's t-test. Now if I go to data, down to statistics, look at all the statistical analysis I can do. Some descriptive statistics, I can do analysis of variance, correlation, and regression, and here we have the t-test. Very simply, it's going to ask me just to choose the variable in the first range. We're going to do this right here. So we just choose all of them. As I said, this is not a video on how to do these lectures. Just want to show you. Let's choose these. That is all the values in my group number 2. And I'm just going to tell it to put the results down in that little block for me. Don't worry about this. Let's see what happens. It tells me it's done a t-test. I just want to expand on this a little bit. Let's say view. Let's just zoom in a little bit so you can see these values nice and clearly. So we saw that the first group had a mean or an average of 99.4 thereabouts, and group 2 had a mean of 108. We're going to compare these means in this parametric test, and look down here. We have one p-value and we have a second p-value. Now this first p-value, as you can see, is a one-tail test. And the second p-value here is a two-tail test. And notice how the one-tail test p-value is exactly half of what the two-tail test is. Now let's look at this. I'm going to hold down Command and I'm going to press U. So every time I do that, we're going to have new random values and we're going to get new we're going to get a new result for our p-value. So let's play around with that a little bit. Let's play around, let's play around. Oh, there's a beautiful one. Now look at this. I get a two-tailed p-value of 0.09. If my alpha value was 0.05 and I were to write a report for publication on these results, I would say, well, I did not find a statistically significant difference. But if I reported this p-value, it would be. It's 0.04. It is less than 0.05. There's a statistically significant difference between these two groups, purely based on the way I chose the hypothesis. And that is, of course, absolutely wrong. And that is why I emphasize so much that the statement of the hypothesis, whether there is a difference, there's one alternate hypothesis, so it can be either more or less, the mean of one group can be more or less than the other, or one-tailed that I already say beforehand that one group will have a mean higher or lower than the other, where I can go for one-tailed. This must be set beforehand. You cannot do the statistical analysis and then, based on the results, then choose which p-value you are going to take. So you can see clearly here what absolute difference it makes, which alternate hypothesis you set for yourself. So for this set of values, we have a p-value of 0.09, but if we do a one-tailed test, 0.04. This cannot be decided once analysis has been done. For that reason, also I emphasize in this course that we really want data to be made available freely. If everyone can examine the data and understand why a certain hypothesis was chosen, it just makes reading that journal article and understanding and believing what is written so much better. Now I've got another little tab down here called fixed. I just want to show you something else as well. Now this time these values are fixed. I can't press Command U and they change randomly. But look at this. I have a two-tailed p-value of 0.07 and a one-tailed 0.03. I might have decided beforehand, well, we are going to go for a two-tailed alternate hypothesis. In other words, we said we don't know the difference between the two groups. One might be more. Group 2 might have a larger mean than Group 1. We said we don't know. It might go either way. And I look through these results now, and I see, well, Group 1 had a mean of 101.5. Group 2 had a mean of 106. So certainly Group 1 had a lower mean, and I go through my data again, and I notice there's this one case of 120.4, which is quite a bit higher than the mean of 101, and I might come up with some reasoning, some logical argument in my head that there was something wrong with that case. I'm not saying it's a statistical outlier. I haven't done interquartile ranges to prove that it is. I just think that, I'm so close with my 0.07, and I wonder what was wrong with this patient, and I can go through the file, and by some logical argument I can decide, no, this patient definitely has to be removed. There was something wrong with that measurement. Let's delete that patient. We can still do it. We still have enough patients in each group. Look what happened. I suddenly, from omitting that one value, have a statistically significant difference between the two groups. See how easy it is to change the p-value and to get to a desired p-value. And I call it desired so that it is statistically significant. Now, I'm not showing you how to cheat. I'm not saying that anyone in the literature does cheat. Anyone who does research does cheat. The point here is that I really believe that data should be made openly available, and we should all know what went into that data analysis. And by doing this course, you now have an understanding of why this is so important and what must be in place for you to trust in a p-value that you do find in the literature.